Hello dear students, welcome back to my channel. Students, look around you. Every light that turns on, every phone that charges, every device you use depends on one simple idea, a circuit. But what actually makes electricity flow? And why does flipping a switch matter so much? In this lesson, we will step inside a virtual lab to build circuits from scratch using the FET simulation. We will start by understanding the two types of electric current that power our world. In direct current or DC, the electron flow in one steady direction like a one-way road from a battery. That's what we will work with today. The other type, alternating current or AC, changes direction many times a second. That's what powers our home. For now, let's master the basics of DC circuits. On your screen, on the left, you can see, can you see on the left the panel here? Yes. This is the toolbox we are having on the left. Think of it as your parts bin for building any electrical device. What we are having here, let's see. We are having wire, battery, light bulb, resistor, switch and many other things when we scroll it down. The battery is our energy source here. This battery is our energy source. Now, it creates a potential difference that pushes the electron. Can you see wire here? Yes. These wires are the roads the electrons travel, on which the electrons travel. Then we have, I will bring one more wire here. Yes. Because this way only I will make electric circuit. Okay, so here I will bring let's do this. Yes. One more I will need. Yes. Now, then we have loads like light bulb here. I'll bring it here, and resistor. This is also the load which uses the energy, electrical energy. And most importantly, we have the switch here, our on-off control, right? So switch. This way, right? Let's do, I have already dragged it here, right? Let's make simple circuit experiment with this now. I have dragged all the things and I have prepared a simple DC circuit here by assembling all the things required to make a circuit. A circuit only works when it forms a complete loop. On your screen, can you tell me it is complete loop or incomplete? Yes, it is incomplete because here you can see the space because the switch is in off position. Switch is open here, right? No loop, no flow. So because it is not a complete loop that you can see on the screen, so no electric flow will be there. So you can see negatively charged electrons are stable. When we connect the battery to the bulb with wires, we give electrons a closed path to move. I'll click, I have already clicked here values. So values you can see, the battery is of 9 volt, bulb is having 10 ohm resistance and switch is showing infinite resistance because it is open. Real circuits follow math, not magic. the voltage of battery and the resistance of the bulb determine how much current will flow. So now let's close it now. Okay, now what can you see here? Something moving? Yes, electrons are moving. Here is where the switch comes in. Right now it's open. See the gap? That breaks means electrons have nowhere to go. This is an open electric circuit. The bulb stays off. Can you see this on screen? Bulb is not glowing. The bulb stays off because the path is incomplete. Now close the switch. I'm here closing the switch. The gap disappears. Now we have a closed circuit. Electrons can now move from the negative terminal of the battery through the bulb back to the positive terminal. The bulb lights up because electrical energy is being converted to light and heat here. Right? One small click and the whole system becomes alive. Okay? This way. Now, can all materials that we put in between the wires will help the bulb to glow? Let's see this. So here we have to change some setup. So what will I do? I'll check. I'll bring one more wire here and will connect it with different materials. Now we'll open the advanced menu to test different objects. So we have a dollar. What will happen if I place dollar in between? Nothing is happening. Electrons are not moving. Even dollar is showing having how can you read it? 1 2 3 4 5 6 10 lakhs ohm. So now I'll put the paper clip here. Okay, before that I have to remove it. I have to remove it and make it suitable for other materials. Okay, now I have put the paper pen in between. It is showing having 0 ohm resistance and electrons are flowing. Metals like paperclip are conductors. They offer little resistance, so the current flows. Materials like eraser. First I have to remove this and then I'll bring eraser or rubber or plastic. Again you can see it is showing around 10 lakh ohm resistance like the dollar bill or the paper. So materials like rubber, plastic, papers are insulators. They block the flow. That's why wires are metal inside but coated in plastic outside, so that conductors can carry the current and insulators keeps us safe. So far students, we have built our working DC, learn to control it with switch, right? And seen why materials matter. You now know the difference between open and closed circuits and between conductors and insulators. Now moving on to your test part. Let's see how much you have understood the concept. For that I have prepared a small test for you. On your screen questions are there. Let's see. First question, what current type is used for community distribution? Is it AC current, DC current, battery or switch? Yes, it is. For community distribution it is AC current. Which of these icons is an EMF source? Light bulb, switch, resistor, battery. It is battery. EMF is electromotive force. What happens to the bulb when the switch is in open state? You remember, when switch is open, circuit will be open. When switch is closed, circuit will be closed. So when switch is open, will be in open state, then the bulb will remain off. What is a typical conductor for electrical circuit? Very easy. Metals are typical conductors. So here we have paper clip. Now fill in the blanks type of question. A dash circuit provides continuous unbroken path for electrons to flow. So which type of circuit will be there? Closed or open? Yes, it will be closed. Materials that inhibit the movements of charge and have high resistance are known as insulators or conductors. Inhibit the movement of charge, so it will be insulators. The dash is component breaks or intentionally breaks or completes a circuit, so it will be switch, SWITCH, switch. In FET simulation, dash flow shows negative charges moving from the negative to the positive terminal. So what it will be? It will be electron. In FET simulation, electron flow shows negative charges moving from the negative to the positive terminal. I hope you understood the concept clearly. Thank you. We'll meet in the next video.